Let's look at the different ways of doing linear regression using technology. I have my TI-84 open here, but the TI-83 and the 84 were remarkably similar. They're essentially the same calculator. So in this problem, I have the drop height and the bounce height for a bouncy ball, and the units of these things are in centimeters. There are a couple of questions to answer, and some of these things I can do already. For example, the first part says, state the explanatory variable. The explanatory variable is the thing that you have control over. It's your input or your x value. So in this case, my explanatory variable is my drop height. My response variable is my y variable. In this case, that's my bounce height. Now, to get this data into my calculator, I go stat, and then I choose enter for edit. And I've already typed this in. But in L1, I'm typing in all of my drop heights. In L2, I'm typing in all of my bounce heights. And if you're following along at home, you might want to pause the video just to get a chance to type this in. As you're typing in the data, you type in your number and then enter afterwards. If you happen to have things inside of a list, so for example, let's say I have some stuff in this list that I want to get rid of, you can always select the name of the list and hit the clear button and then enter to clear out some stuff if you already have things in your list. Once you have the data typed in, you're going to go to stat and then calculate. And then I'm choosing the option linear regression ax plus b because this reminds me of mx plus b, that a is my slope, that b is my y-intercept. So I'm going to choose the fourth option down there. It's going to ask me where my X list is. That's my explanatory variable, and that's in L1. If it doesn't say L1, all of your L's show up in blue down here, so you can do second 1 to get L1 to show up, and second 2 to get L2 to show up for your Y values. I leave everything else blank, and I go to calculate. I hit enter. And mine gives me my A and my B. So it's calculated my slope and my y-intercept. My equation looks like y equals 0.674x plus 0.3889 or so. Now, the one thing that didn't give me is my r squared, or my r. So TI-83s and 84s can be a little bit finicky about that because it doesn't want to calculate all of your values for you. It doesn't have diagnostics turned on by default. So if you're in a situation like I am, and you only need to do this once, don't worry, hit second and then 0 to pull up the catalog. And I'm going to scroll down to the letter D, or hit the letter D just to jump there. And I am looking for something that says diagnostic on. And I see that right there. This is what happens when you hit buttons too fast for your computer. Great, diagnostic on, and then enter. It doesn't look like it's done anything, but I just want to show you what happens now when I do stat calc lin reg ax plus b again. Now when I go down and hit enter, it'll give me my slope and my y-intercept. It'll give me my line of best fit like before, but it will also give me my correlation coefficient, my r, and my r squared. This is the percent of variation accounted for by my model, and it's how good my fit is. So I would say this is 97.7% like a line. That's a really rough way to think about it, but that's an okay way to think about it. It's 97.7% like a line. Let me show you how to do the same thing now, but inside of a TI-89. So here I have my TI-89 calculator. And it's going to be so similar to my 84 that I'm even going to leave my 84 up there. But I'm going to go into apps. And then inside of apps, I'm going to choose this option for stat list editor. Inside of list 1, I'm typing in all of those x values that I had at the start of the video. And in list 2, I'm typing in all of those y values. Now, up at the top where it says calculate, this is where I'm going to be doing my linear regression. So I'm going to hit F4 for calculate. I'm going to choose the option for regressions. And I'm going to choose the second one because this looks like AX plus B. That's sort of like MX plus B. It's going to ask me where my X list is. It's in list 1. It asks me where my Y list is. It's in list 2. I'm leaving everything else alone. And when I do this, I get the same value for my slope, 0.6747. So I could drop that in for my A for my equation. And for my B, it's giving me 0.3890 if I round this thing. And I could plug that in for my B. Again, my R squared is very good. The closer your R squared is to 1, the better the fit. And in general, if you have an R squared around 97%, that's a really, really strong fit. So I've seen this now using both the TI-83 and the 89 calculators. Let's see what this looks like inside of Geogebra. When I open Geogebra up here, I'm going to choose the option for spreadsheet. In my X list, A here, I'm going to be typing in all of my drops. In my Y list, my B, I'm going to be putting in all of my bounds. And I already have this saved to my clipboard, so I'm just going to copy and paste that in. After you've typed in your data in the spreadsheet, click and select it so it's all highlighted. Go to where it's got this histogram, but instead of choosing histogram, choose this second option, this 2-variable regression analysis. When you do that, it gives you a scatter plot. That's a pretty nice scatter plot. This looks fairly linear. In fact, now I can see why that R squared was so good. This is really, really close to a line. For regression model down at the bottom, choose linear. And then there's my equation, just like before. There's that 0.6747x plus 0.389, like we were seeing with the other graphing calculators. If I hit this button up at the top, that sigma x thing, this will spit out for me my R, that's my correlation coefficient, my R squared, as well as some other information that I don't necessarily need, like the average of my x's, the average of my y's, the standard deviations of my x's, and the standard deviation of my y's. These are numbers that you could use to find this equation by hand, but I already have an equation down here at the bottom that I'm feeling pretty good about. So again, that's how I find the line of best fit for linear data sets using technology. I'm doing lin reg ax plus b in my calculator, or in Geogebra, I'm selecting it all, and I'm choosing this 2-variable analysis, and then the line option.